Okay, so yesterday we discussed doing addition and subtraction. Today's lesson will consist of doing multiplication and division. Just the basics of it. We're not going to do long division and we're not going to do big multiplication problems. We're just going to try to nail down multiplication right now. So as before, when I described it in the end of the previous video, I described it as like a grid type structure when you do addition. And I didn't discuss anything about division. So let me just reiterate, because this is probably what's going to matter. Right? So we have in our world a plane. We're going to call this little square here the plane of existence, and we can go up and we can go right, and we can go back and forth from those directions. And what we will do with these two little dimensions here is we're gonna end up creating figures. So let's create a grid of 3 going to the right and a 3 going down. So all we gotta do here to make this grid complete is we gotta match all of them up. This 3 by 3 here is all complete. What we have done here is multiplication in a sense. When I said 3 by 3, it kind of looks like this. We are doing 3 times 3, and 3 times 3 will give us 9 here in this example. It does this because we have set the grid like so. And I can show you another example of this grid, right? If you're not seeing the grid, look at these lines. These lines show the up and down lines and the left and right lines. Once they've all intersected and we've not left any gaps, we have completed our 3 by 3 and we have our answer of 9. So now we can discuss what multiplication actually does here, aside from just doing that as an example. It represents the addition, the repetition of an addition of a value, defined by one number and whatever we're multiplying it by. 7 times 2 is the same as 7 plus 7. This will equal 14, as represented by the grid structure. It'll become 14. And that's really all you need to see here, because now we have already done this enough times where I think you guys can figure it out on your own. So you know that this will be 14. Alright, so we have that figured out now. Let's do a little problem here. This will be quick, very simple. I want you guys to do 3 times 2. 3 times 4. You can pause the video now, because in just a second I will give you the answer. Okay, so now we have the answer here given. 6, because 3 plus 3 is 6. And the answer here will be 12, because 3 plus 3 plus 3 plus 3 is 12. But this method is a little bit slow. We'll run into numbers that will be hard to add really quickly, and we want to be fast, which is why I need to ask you to do me a little favor. I memorize numbers 1 through 12. So you're going to need to learn 1 times 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12. And then 2 times 1 times 2 times 3 times 4 times 5, and so on and so forth. You will need to memorize these numbers as it'll make things run a little bit more smoothly. So, what I mean by that is like a number grid here. We're going to have a little grid. You could probably do this in a quick Google search, where it shows you in a row what the values will be. 1 times 1 will be 1. 2 times 1 will be 2. And 2 times 2 will be 4. 3 times 1, 3. 3 times 1, 3. 3 times 2 is 6. 2 times 3 is 6. And 3 times 3 is 9. And it'll continue to go on until you reach 12. Once you've completed this grid as your assignment, you will be asked to memorize the values, and you will be tested on them. And by tested, I mean by at the end of this week, we will discuss the whole chart. We will be doing small little instances of it, and you'll be required to memorize them. But it's fine if you don't get it right, as this is all just part of an experiment. So don't worry about it too much if you can't memorize them. Just know that this is how multiplication is going to be in the long run. It's going to be fast, it's going to be strong and precise. So, just for today, you'll only be required to remember to 5. And then on the next day, you'll be required to remember to 10. And then on the day after that, to 12. And then you'll be fine. Once you have memorized that, you're good. So, let me just expand our canvas a little bit just to show you what it actually does look like, so I can give you it right off the bat without having to worry about it. My mouse is breaking here. It's causing those little gaps. Alright, 4 times 1, 4, and 5. The times 1s and times 2 will probably be your easiest ones, as they just are just in of itself. Two times 4 is 8. And 2 times 5 is 10. 4 times 3 is 12. 3 times 5 is 15. 4 times 4 is 16, because 4 plus 4 plus 4 is 16. Oh, 4 plus 4 plus 4 plus 4. My bad. I only said that 3 times, but it sounded like 3. I mean, it sounded like 4, but I said it 3 times. Anyway, 5 times 4 is 20. And 5 times 5 is 25. And there you go. You'll be asked to remember to doing this, because on further examples, tomorrow will be consisting of this kind of stuff. The other stuff, if you don't know it, it's not going to matter that much. I'll just tell you what it is, but you will be expected to go to 12. If you could do that early, that'd be really good. Alright, so now we'll be moving on from this grid. Make sure you screenshot it, take a picture of it, or find an example of this somewhere else. This will be your study guide for tonight. Okay, and that's it. That's all there is to multiplication. Multiplication's basics, at least. You will only be responsible for memorizing this stuff. You will not be doing any big, long multiplication problems. We won't be doing that kind of stuff. Because in order to do that, you need to have this memorized. And you guys haven't really reached it yet. Because eventually, you're going to be asked to do like 37 times 42. And this requires a lot more than just memorizing this. You're going to go to 12, so you can at least understand the shortcuts, because 11 and 12 aren't really that necessary. Just going through 1 through 10 is good, but knowing 11 and 12 will be life-saving because they are pretty common and will appear a lot and can help you move a lot faster. That is why I'm expecting you to go through 1 through 12 on this grid here. Alright, so if you can solve this and you can show me how it's done in the comment section, that's good. I'm not asking you to do that though. Just know that eventually we're going to be doing that. That's what you will be expected to do. You won't be doing the memorizing, you'll be expected to know how to solve that using this. Because you're going to be using a method that requires you to multiply the 1 into the top two numbers and then adding a 0 at the second addition here because you're doing the second place. It's complicated and it requires you to do a lot of math. Alright. Now we are going to be moving on to division. Yes, this little symbol here. You probably recognize it. You've probably seen it. What this is essentially a parameter of subtraction defined by a value. So you have, let's say, 10 here. 10 apples, 10 bananas, 10 whatever. But you want to give it to 3 other guys here, right? We got Billy, May, and Sam, all right? We want to give all of them an equal amount of it. Now this is going to be hard to do because we don't really have something that revolves in common sense here. Division is a very difficult thing to do at a high level and requires you to go into decimals. So to do division, before we can talk about division, we're going to need to talk about decimals. So believe it or not, this one here actually has an understood 0 to the right of it. But we don't need to write it down. This is the same as 1. Decimals are an extra place for something smaller than what we call whole numbers. Whole numbers are numbers that don't have any decimals. There are no decimals involved whatsoever. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and above will all count as whole numbers. But if you have 1.5, for example, or 1.0001, they are not whole numbers because they have decimals in them. The decimal is what makes them not whole numbers. They are fractions. They are fractions of a number. I can represent this with multiplication. We have here a 2 here, right? And we want to know oh yeah, actually, let's do this differently. This won't work at all. Right. Let's write down a fraction here. Right. 1 over 4. This is represented as a quarter of something. So a quarter of 4 would be 1. A quarter of 4, because if you do this times 4, you're essentially doing 1 times 4 plus 1 over 4 plus 1 over 4. So as we have it here, these bottom numbers here, the denominator, are actually not going to be changing when you do the addition. They represent how much can be held within the fraction. This right here determines how much of whatever defined division is happening here. This will all equal up to 1. So we have 1 in total. We have all these added up. Because these numbers won't change. Remember, these are the denominator. These are denominators, and top are the numerators. Numerators are what can be changed. We can actually add another one here, which would change what this all is. So we'll do that in a bit. Remember that all this will equal up to 4 over 4. And once we've had the numerator the same as the denominator, this will always be 1. It could literally just be any number. It could be literally whatever number you want over any number, and it'll always be 1. With the exception of dividing by 0, which you might know because of some funny jokes on the internet running about, saying this is not possible. What do you do here? You can't do that. It's not possible. It's just not gonna happen. You're gonna make it all awful. No. No. We can't have that at all. So then, what is 1.1 in a fraction form? What is 2.3? How can we do that? How can we turn these into the fractions that we were just previously discussing here? Well, it's a bit of a trick here. You have to understand that when you are going in between 1 and 2, that you gotta go deal with fractions. In order to do that, you need to represent this with decimals, the number in between them, because there's only a whole number distance between 1 and 2, and that distance gets you to 2 from 1, and to 2 to 1. You have it easy when you have the whole number in between. You could just say that's 2, but right here, the number up here isn't really a whole number. It can't exist like a whole number, because the only thing that comes after 1 is 2, and the only thing that comes before 2 is 1. Which is why we gotta deal with these decimal numbers. The middle of 1 and 2 would be 1.5. And I'll explain to you in a bit. You can explain this in a lot more simpler way using a number line. A number line is a way of measuring the distance between numbers. So here's 1, here's 2, and right in the middle it's going to be 1.5. How we get there is using the ones placed within the decimal sign, which is actually called the 10th place. It's proper to call it the 10th place. The 10th, let me just spell it out here. Yeah, it's proper to call that the 10th. What follows up the 10th is the 100th, and then the 1000th, and then so on and so forth. So yeah, we'll have that all figured out. Right now we're only focusing on the 10th place, which is a 0.1. So we're going to keep adding 0.1s to get there. So this is 0.1, this is 0.2, this is 0.3, this is 0.4, right? And now we get to 0.5. Now we get to 0.6, 0.7, 0.8, 0.9, and then finally, if we add another point, we'll get to 2. So that is the distance between these two numbers. Good. We'll discuss this now. You understand that this would be that? Okay. So then tell me, how would you do 3 and 4? Does it make sense to you? Can you solve? Can you tell me what the middle is? Can you tell me what this is right here? Tell me, what is this right here in particular? What value is this? If you said 3.8, you'd be right, because this right here is this middle right here is 3.5, and we can count to get there. We got 3.1, 3.2, 3.3, 3.4, and finally 3.5, and 3.6, 3.7, 3.8. This is 3.8. So we're done here. You have learned how to do decimal counting. Alright, so now we can start beginning with the actual division process. Division is going to be a little bit tricky to handle, so be prepared. It's kind of like multiplication, but going backwards. Let's start off with something simple. 8 divided by 2, which can also be represented as 8 over 2. However, this 8 divided by 2 is not the same if you add, let's say we have here a times 2. Yep. Oh, that's a bad 2. Times 2. Right. Now it's going to be not going to be this. The reason why is because actually what this implies here is that it implies that this is a priority problem. This needs to be done first. And it understands that there are actual parentheses here, which then this would be true. They'd both be the same thing. Right here, this stuff would be pretty much the same, but only if these parentheses are here. We'll get to parentheses in a second. Just don't worry about it right now. Just understand that 8 divided by 2 and 8 over 2 will be doing the same thing here. 8 divided by 2 is telling this 8 here to split evenly into 2 pieces. So let's count. 2, 3, 4, 5, 6, 7, 8. How do we take this number here and make it so that there are 2 equal pieces of it? We can count. We can clearly see there are 4 on each of these rows here. But let's make it a little bit more interesting, shall we? Let's say we can't do that. Let's just say, oh no, this is still not possible. Like, I don't know how to do this. We can start off by doing backwards multiplication. So let's go ahead and say that we have a row of 2 here, because we have spaced them out so there actually are a grid that is covered here. We have 2 here on this side and 4 on this side, right? If we multiply them all together, we will get 8. You see that we have an 8 here in total, but we have a missing 4 within this problem. to check your work, you can always do this method here. Align it in the shape of a grid so that this is true. Don't have anything floating here, because this wouldn't work here if you had something arranged like that, or if you had it arranged like, say, like this, right? That won't work. It has to be arranged in a grid for this trick to work, because otherwise you're not going to get it right. 8 is assembled in a grid. This is helpful if you have a grid-like structure, but if you can't do that, let's say if it was 9, for example, you'd have an extra 1 there. You'll be dealing with decimals, which is a lot more trickier. But for now, let's stick to this. We have the 4 here. This extra 4 here will be the answer here. Why? Because we need to separate it into 2 equal pieces. 2 equal pieces. This right here and this right here are both equal to 4. These two are equal to 4. They're equal. 4 equals 4. We have 2 of that. 2, we want 2 of that. So each piece, once we divide it in 2, is equal to 4, which is what this division is telling us to do. The answer here is 4. And can you tell me what would happen if we were dividing by 4? What would happen, say we were doing 8 divided by 4? What would the answer be? Now pause to think if you really need to, because now I'm going to tell you the answer. Guess what? It's actually 2. Yep, they just switched places. Believe it or not, that if you decide to make 4 groups, right? You don't want to know what would happen? This is what would happen. This 2 right here. You need 4 groups. And guess what? You have 4 groups right here, circled in the purple. And we have done it yet again. We have shown you how it is all done. Okay, so if any questions on that, do let me know, because now we're going to be moving forward. Should probably mention you should go back just to see. Okay. Now we need to talk about an actual problem that might occur later on. Alright. So let's say you're doing your taxes or whatever, right? And they're asking you for a thing called percent, right? This is gonna be a little bit problematic because percent isn't something you really know about if you only know about fractions and decimals. Except it could be if you understood that percent is talking about per 100. Believe it or not, cent means 100. Percent here is talking about a fraction of a certain amount of money. So let's say someone asked you for 6% of $20. What that essentially will be asking you to do is to multiply $20, right, by 0.6, or by multiplying the fraction here of the 100 So to do this, all you really need to do is understand that there is an understood 1 here. When you're dealing with multiplication, this sort of things get a little bit tricky here. Yes, believe it or not. You need to have a 1 down here for this to truly make sense. Otherwise, you're going to be changing this. Because, let's say it wasn't there. Now you're going to have a problem with this, because this is going to multiply into that, and you don't want to do too many multiplications. 20 times 6. This is something I didn't tell you about, but you will learn eventually to do it. 20 times 6 is just 20 plus 20 plus 20 plus 20 plus 20 plus 20. but we're gonna just say this right now, that you could do 6 times 2 to figure this out faster, and then add the 0 at the end, because the 0 there is talking about the ones place here, and you're really only changing this number here, because the 6 can't change to 0. 0 plus 0 plus 0 plus 0 plus 0 plus 0 will equal 0 no matter what. So don't worry about that much. This will be 120. But now we have this 100 down here. We didn't forget about it. It's still there. Believe it or not, this is the same as saying 12 over 10. It's the same because they both have a 0 in the beginning, but now it's a little bit tricky to understand here, because now we're going to go into decimal territory again. No! Okay, so where was I? Right, we're going to do decimals now. We're going to move into decimals. Believe it or not, this is what's going to happen here. We're going to do 12 over 10. Anyway. Well, because they're both even numbers, you could divide. You can divide them both by 2, which is what we're going to do here. You can simplify it even further by dividing the top and the bottom by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. This is why you're asked to remember all the way 1 through 12, so you can do the backwards division and also memorize that too. Because once you memorize that, you can also memorize this and have it done fast. You're basically taking the even thing. 6 plus 6 is 12. 5 plus 5 is 10. You have it all figured out. And now we have this. Okay, so believe it or not, we can do the trick we did earlier where we took the 6 and broke it down to 2 pieces. Believe it or not, yes, it's true. It's right. We have a 5 and a 1 here, right? We could take them both apart. 5 over 5 is equal to 1, and this is equal to 1 over 5. Yes. So then the answer would be... Can you say it before I'm done doing this? The answer will be 1 plus 1/5 and that 1/5, you take that apart. We're going to do decimals. I'm going to turn that into a 0.2, because 0.2 plus 0.2 plus 0.2 plus 0.2 plus 0.2 is equal to 1. To show that, you can do this. Oh, I'm running out of space here. I'm going to take a shortcut. This is all equal to 1. So it's 4 to 6 to 8 to 10, to 10, and because of the decimal there, it's 1.0, and 1.0 is equal to 1. That's how I know that like 0.2 is an even distribution of 1/5. So that is why we have our answer 1.2. I don't explain this very well because I'm actually very far ahead that I've actually forgotten how I did it in the first place, other than I just know it is as that. My brain tells me different than what it actually looks like to everyone else. So I'll try to break this down a little better. So we do have our answer here, 6% of 20. If you were to actually put this in a calculator, this would come out as the right answer. But I never really discussed why 6% is equal to 0.06. That's because if we put 0.6 will be implying that there's a 0 there, which is 60%. 60 of 100. This is 6 of 100. 6% is talking about per 100 because that's what cent means. Which is why this is called the 100th place. This is why it's called the 10th place. And that's why the left is called the 1's place. And you know, everything comes full circle. You'll be able to understand why everything comes to be. Now, that one thing left to do here is to explain why 1/5 is equal to 0.2. So previously I showed you guys how to do number lines, and well, that's close enough to show you how much of distance is there. So let's do it yet again. Let's do another number line. Yeah, to discuss how we know that 1/5 is in fact 0.2. We know this because if we make a number line here of 1 to 2 here, or let's just make this 0 to 1 for simplicity, right? There's not going to be a halfway point. There are 5 marks in this here. Well, actually, no, there's not 5 marks. There's actually 4 marks. But that can be explained because 5 over 5 is 1. Their 5 marks are right here. See? We're moving to 1. This is equal to 0.2. This is equal to 0.4. This is equal to 0.6. This is equal to 0.8. The pattern here is that it's going up by 0.2. And there are only 5 pieces to choose from here, because 5 over 5 is 1. So we have to deal with the 1 over 5, 2 over 5, 3 over 5, 4 over 5, which is what these are. Oops, I'm gonna fix that real quick. Let's make this look like an actual 5 here. There we go. So yeah, it makes sense now. There are actually 6 numbers within this fraction here. But we don't really need to talk about 0, because 0 is still just 0. A 0 over anything will be 0, as long as it's not 0 that it's over. And as long as it's the same as the denominator, the numerator is the same as the denominator, it will equal 1. There are only 4 pieces to discuss here, and that is what's happening here. We know that 1/5 here is this. They are even numbers. It's evenly distributed. It's 0.2. So let's make this a little bit easier to discuss. Let's have 10 divided by 2 once again. 10 divided by 2 is 5. Now we have it backwards. 10 divided by 5 is equal to 2. The 10 here in this case being a whole number instead of being a whole, instead of being smaller than the 5 here. It's a bigger whole number than the 5. You can get up here as a whole number here. This answer, I mean. Oh man. We gotta wrap this up. I'm getting really tired. So then, once we're through with that, we could discuss the understood 0 here that exists. We can make this work, and there's the same circumstances as long as we add a decimal. there's a decimal going this direction here, right? We have one arrow going in. So the answer, despite this happening, is also going to need a decimal to go jump up to. Which is why 1 divided by 5 equal to 0.2. It is because, remember, we discussed that 1.0 is the same as 1. They're both the same number. It's just that we don't need to write down that 0 there because the 0 doesn't really matter now, not too much. Okay, so now we explained the fraction here. We've explained that 1 over 5 is 0.2. We've explained we explained that it's 0.2 here because this is the same as writing it as 1 divided by 5, and 1 divided by 5 is the same as writing it as 0 over here, and we can replicate this example right over here. Just as long as if we add a decimal here, if we're moving this decimal here, we got to move the decimal here. But that's only if it's on the left side. We're not going to talk about the second number here, because if you make that a decimal, you're technically multiplying instead of dividing, but we'll be too much ahead. Let's go ahead and discuss that real quickly right now. So, yeah, everything is happening at a fast rate. It's going to get slightly faster because I expect you to know a little bit of some math here. Yeah, 0.5, 10 over 0.5. 10 over 0.5 is the same as saying as 10 divided by 1/2. Half of 10 is 5, and we're doing decimals. I turn that in, and of course comes out to be a half. So that is why 0.5 is equal to 1 over 2. 0.5 is equal to 1 over 2. Man, I'm really tired. And we have a fraction underneath a fraction. What happens here is that we actually have to get rid of this 1 here. The 2 here on the bottom of this fraction actually ends up being multiplied to the top. This is a neat little trick. So what we're doing is in reality is 10 divided by 1, which is equal to 10, multiplied by 2, which equals 20. 10 plus 10 is 20. So simple. Very easy. So whenever you have a decimal that you're dividing by, right, it's essentially just multiplying. Whoops, that's a 20. That looks like a 26, but it looks like a 0. There we go. And that's our answer, right? We found our answer. We have everything all done. We have solved division. We have solved multiplication. We have solved division. Your homework for tonight is to do one thing and one thing only, and that is memorize your multiplication chart. Yes, believe it or not, that is going to matter. You will need to do that. Go back to the set timestamp or whatever, and here, let me see if I can actually bring it up. Let's see if it still exists or if it disappeared for good. Nope, it's gone. Okay, well, you have it in the video. Just make sure you have it in your head. Memorize 1 through 5 on the grid. 1 through 5 going down and up and to the right. Memorize all those numbers, and then tomorrow we'll discuss that a little pop quiz, I suppose. Although it's not only a pop quiz since you'll know it's coming. And tomorrow we're going to talk about long division and multiplying. We're not going to be doing any of that. I have to go now, so yeah. Thank you all. Take care.